Welcome back, Algebra 2. I kind of jumped the gun a little bit in that first video. I forgot we were supposed to check our work in decimals, okay? And like kind of talk about what that means to check our work. So let's go ahead and do that. The first thing I want us to do, we're still looking at example 1. You should have that written out in front of you in your notebook. So let's type out that function here in this first box. It looks a little different on my PC. You should still be able to do it. You're going to press on it with your finger in that number 1 box on the left-hand side of your screen if you're on your iPad. We're going to type in 2x cubed. Okay, you have that little exponent button on your, and actually I can pull up the keyboard to show you because it is the same keyboard. And I'll use this just so I can show you which buttons to press. So 2x, use this one to go into the exponent, cubed, and then plus 8x squared. I'm going to cheat and just use that one. And then minus 6x minus 28. So minus 28. Okay. And I'm going to press this so I can get rid of my keyboard. But here's our graph. Okay. Now you can use your fingers. You can, in your case, since you want to zoom out, you're going to pinch. So double tap with your 2 fingers, not double tap, sorry. Put your 2 fingers on the screen and then move them closer together, and that'll zoom out. Okay, just so you can, and then you can drag around to kind of see what this function looks like. Okay, so we kind of see lots of different curves. We go up and then down and then up again, right? So how are we going to check our work? What does that mean? Well, what were our answers from this past problem? We got -2, comma, -1 plus 2 rad 2, comma, -1 minus 2 rad 2. Okay, so these are our zeros for this function. Remember, zeros, whenever they are real numbers, they're the x-intercepts of our graph, okay? So on your end, you can actually just, if you see our x-intercepts, they're here, here, and here, you can use your finger, just press on where it should intersect, and you'll see one of them is -2, good, right? That should be the case. That's one of our zeros, our x-intercepts. And then you have the other 2. You have -3.828. Write that down somewhere under the example that we're on. -3.828. And I would write x equals in front of it, actually. And then also write x equals, let's look at this other one, 1.828. Now that looks a lot different from our other 2 zeros. Our other 2 zeros that we got algebraically are -1 plus 2 rad 2 and -1 minus 2 rad 2. Well, those are actually the same numbers. Okay, let's prove that. Go into the next box. Remember, this is actually also a calculator as well. Pull up your little keyboard. It'll already be there for you, I'm pretty sure though. We're gonna type in -1 plus 2 square root symbol 2. And look at the output. Okay, they rounded it, but this is our 1.828. Okay, so good. That's actually one of our answers. One of our answers is correct. Let's make sure with the other one. -1 minus 2 rad 2. -3.828. Awesome. Okay, so our answers are correct. The radical ones, the ones that are irrational, these are both irrational numbers, but they're still real. Okay, so good. Our work is complete. We got the correct answers. Okay, so now let's go ahead and continue. I'm gonna hopefully have a smooth transition here. Okay, and we're back to our notes. Okay, so let's continue our conversation about, you know, we had 3 solutions and our polynomial was a 3rd degree polynomial, okay? So in your textbook, you don't have to do this, but you can go to section 5.6. You're going to notice it's called a different title. That's because we're not going to go as in depth as the book has us go, just because of for the sake of time. But you're going to find in section 5.6, and actually this particular thing is in section 5.7, called the fundamental theorem of algebra. the fundamental theorem of algebra says something specific, but a result of it, something that we're kind of more interested in, is that an nth degree polynomial function, I'll change the color of my highlighter. I don't really like any of these colors, but we'll just go with green. An nth degree polynomial function, so whatever degree it is, that's the n, has exactly n zeros. Okay, so a third degree polynomial will have 3 zeros. A fourth degree polynomial will have 4 zeros, etc., etc. Okay, and now let's kind of talk about what that means. What are the implications? Well, sometimes the reason why it's zeros and not, say, x-intercepts is because zeros can either be real or complex. Okay, that complex part means we can't limit this to x-intercepts because they can be complex, and our x-intercepts are never complex. And then some zeros are repeated. Okay, sometimes I'll have a 5th degree polynomial, and my only solutions are x equals 0 and 1. Okay, well, that means that 0 was repeated twice, and this can be in any order, and then 1 is 3 times, so times 3. And it could be the other way around. I could have 0 happen 4 times. I could have 1 happen 1 time. All right. So it really just depends on the graph. And we'll go ahead and look at a few cases of that to kind of talk about that. Okay. I accidentally wrote on my written work, so I can't erase the twice, or else it'll erase the example as well. I'll just erase it and rewrite it. There we go. Okay, so let's do another example. X cubed, this is supposed to be plus x squared minus 12, given that f of 2 equals 0. And we're going to check our work again using decimals when we're done. All right, so find all the zeros. We're given one of them. Let's start our synthetic division. Okay, f of 2 equals 0. What does that mean? That means 2 is a 0. Which then also means that x minus 2 is a factor. Okay, so then synthetic division, 2 in the shelf. And then we have coefficients 1, 1, 0, negative 12, right? Because this is our x cubed, x squared, x, we're missing the x term, so we need a placeholder of 0, and then the constant. Okay, nice horizontal line. And then, sorry, I had a brain fart. First thing we need to do is bring down the 1, bring down the very first coefficient. 2 times 1 is 2, 1 plus 2 is 3. 2 times 3 is 6, 0 plus 6 is 6. 2 times 6 is 12, negative 12 plus 12 is 0. Yay, remainder 0. We need a remainder of 0 because we know this is a factor. If you got something other than 0, then you need to do it again because this is confirmed a factor, so it should divide into this polynomial evenly, right? Remember, at the end of the day, when we do this synthetic division, we're taking x minus 2 and dividing it into our polynomial x cubed plus x squared plus x minus 12. Or no, sorry, yeah, I was correct the first time. X cubed plus x squared minus 12. Okay, cool. So now we factored it a little bit. We ended up with x minus 2 times, remember this is x squared, x constant remainder. So x squared plus 3x plus 6. Okay, so now this is equal to what we just got, x minus 2, x squared plus 3x plus 6. And if we're trying to find the zeros, we set it equal to 0. And now we go from there. So we already know one of them. This one we already got for free, so it's not any new information. I don't need the parentheses there, I apologize. X minus 2 equals 0. That gives us x equals 2. That was already free information that was given to us, okay? But let's just account for it. And then x squared plus 3x plus 6 equals 0. Can we factor this? Factors of 6 that add up to 3, well, we either have 1 and 6, but that adds up to 7, or 2 and 3, which adds up to 5. So no, which means we have to resort to quadratic formula. So let's do that. X is equal to, A is 1, B is 3, C is 6. So negative 3 plus or minus the square root of 3 squared minus 4 times 1 times 6. That's a 6, I promise. Divided by 2 equals negative 3 plus or minus. Clean up the insides. This is 9 minus 24 divided by 2 equals negative 3 plus or minus the square root of negative 15 over 2. Okay, so now here's where the distinction is. If I was asking for x-intercepts, you would just stop here because you see that negative radical, or sorry, radical with a negative inside, meaning that that's not going to be an x-intercept because that's not a real number. But because I want all the zeros, this is a complex number, I'm okay with this being included as a solution, okay? So equals negative 3 plus or minus. If I think about rad just 15, that's equal to rad 5 times 3. That's all I can do to simplify, or those are the only factors aside from 1 and 15. And neither of these have perfect squares. So we can't really do much else with that. So this is as the 15 is as simplified as it gets, but I can factor out that negative as an I, square root of 15 over 2. So that's as simplified as it gets. Okay, x equals. So my two solutions from there, we have 2, are 3 plus I rad 15 over 2, and x equals 3 minus I rad 15 over 2. Now, of course, you can leave it like this, especially when you input it into delta math for your practice sets. But I like to separate it out just to show how many solutions we have. So we have, let me do this a different color, 1, 2, 3. Okay. Did we pass the fundamental theorem of algebra? Yes, because the degree is 3, we should have 3 zeros. Okay, 2 is a real number. These two are both complex, but that's okay, they're still zeros. Okay, let's switch over to Desmos to see what that looks like, because according to this, we only have 1 0, 1 x-intercept. Let's see what that looks like. All right, we're back in Desmos. Let's go ahead and clear what we have here, right? You can press these x's to clear. All right, let's put in that function, x cubed plus x squared minus 12. Okay, so I'm gonna put this keyboard down and I'm gonna push down a little bit because mine is a little weird. But look at our function this time. Okay, this is a cubic function. You've seen a few examples of cubic functions already, kind of like that snake-looking graph, okay? If you notice this function, it only has one x-intercept, and that kind of matches up with the fact that we only had one real zero. This 2, 0, and our 0 was 2, okay? So good. It's really hard to check our work here with this one because we have an imaginary solution, and our imaginary solutions, this is a real plane, so we can't really graph it. But the way that we can kind of confirm our answer a little bit is that, you know, we saw we only had 1 0, therefore the first thing you should think is, okay, sorry, only one real 0. Okay, that means that I only have one x-intercept. So if I see more than one x-intercept, I might have gotten one of my solutions incorrect. Okay, but we're good here. We got only one x-intercept. Okay, if it crossed any more times, that means that we have more zeros, more real zeros, which means that either we typed something in wrong or we did our math incorrectly. Okay, so we're good here as well. Let's go ahead and switch back to our notes. All right, let's pick up with one last example. Find all the zeros of f of x equals x to the 4th plus 9x cubed plus 23x squared plus 3x minus 36. Given that, this time we have two factors given to us, x plus 3 and x minus 1 are factors, okay? So now they directly told us here are the factors instead of telling us using that function input notation, okay? So notice that in the previous two examples, we dealt with cubic polynomials. Here we're dealing with quartic or degree 4 polynomials. So they're giving us two pieces of information for a reason. So let's talk about that once we use one of them, okay? You'll see why they had to give us two pieces of information instead of just one. All right, so let's start our synthetic division. Let's use the first factor, x plus 3. That means we're going to put -3 on our shelf. And then let's line up our coefficients. So no missing terms. We have 1, 9, 23, 3, and -36. Okay, so do our little horizontal line. Bring down our first coefficient, 1. -3 times 1 is -3. 9 minus 3 is 6. -3 times 6 is -18. 23 plus -18, that is 5. -3 times 5 is -15. -15 plus 3, that is -12. -3 times -12 is +36, which gives us a beautiful, gorgeous 0. Okay, so we found a new piece of information. We know that this polynomial is equal to x plus 3 times, here are our coefficients, this was x to the 4th, x cubed, x squared, x constant. So now it's down by 1, x cubed, x squared, x constant remainder. So I have x cubed plus 6x squared plus 5x minus 12. Okay, normally in the past, what we've done is, okay, now that we factored it down, we ended up with a quadratic that we can either factor or we can stick into the quadratic formula. But here we have a little bit of an issue. Notice the degree of what's left, x cubed. Okay, so I could try to factor this, but if you notice, we have 4 terms. That means we have to try factor by grouping as our only resorts, but that will not work here. Okay, if you try it, you will see that you do not get the same 2 factors from your 2 groups. Okay, so that's why this extra piece of information is important, because we need to do synthetic division one more time to get this down to something we can work with, okay? So we're only gonna focus on this chunk, okay, this polynomial, using this factor, okay? And we're allowed to do that because both of these are factors. So both of them can divide into this polynomial, and it can also divide into a remaining chunk, right? So had I started with 1, I would have gotten something different here than I would have used -3. Okay, I could have done it in any order. So let's use 1 in our shelf and then use these coefficients. So 1, 6, 5, and -12. Ooh, -12, not -2. Okay, bring down our 1. So 1 times 1 is 1. 6 plus 1 is 7. 1 times 7 is 7. 5 plus 7 is 12. 1 times 12 is 12. -12 plus 12 is our favorite number, 0. Cool. So now this is x squared, x constant. So now this is actually equal to x plus 3. That was one that tagged along for the ride. Then I factored out an x minus 1 from here because I know x minus 1 divides into this, and I use synthetic division to divide. What am I left with? X squared plus 7x plus 12. Awesome. Okay, now let's try to factor this down, or actually let's go ahead and we can start setting things equal to 0 because now we know this quadratic will either factor down or use quadratic formula. Okay, so x plus 3 equals 0, right? Because remember, at the end of the day, and then let me use a different color actually. At the end of the day, so if I set this equal to 0, this and this and this are all the same, just written differently. This one's slightly factored down, this one's factored down a little more, and then once we find these two, the factors of this or the solutions of this, then we'll fully factor it or just find all these zeros, okay? So x plus 3 equals 0, I'm writing that in blue actually. And then x minus 1 equals 0. Those, remember, those are going to be our free ones, right? We already know that -3 and +1 are zeros. Not necessarily immediately because they're disguised here, but if you solve these for 0, then you would have gotten these numbers, okay? So now I just need x squared plus 7x plus 12 equals 0. And can we factor this? Factors of 12 that add up to 7? Oh yeah, this is going to be x plus 3, x plus 4, because 3 plus 4 is 7. So then we set these equal to 0. We can get x equals -3 and x equals -4. Okay. So notice that we got -3 twice. Okay, so that's okay, right? We need to have 4 solutions or 4 zeros. We do have 4, right? Because it's a degree 4 to begin with. But it's, in this case, there's only 3 unique solutions because that -3 is repeated. Okay, but we do really have 4 solutions. Okay, let's quickly move over to Desmos to just confirm these answers, and then we will be done for this section.